Hello and welcome to Channels, the Nextflow podcast. You're listening to episode number 32, going out in March 2024. My name is Phil Yules and I'm a lead senior product manager for open source software at Secura. And I'm sitting here in sunny Stockholm. We've got a really fun episode with you tonight. We've got an interview with Josh Chorlton. Now, I feel like it's good to give a little bit of a backstory here. Josh, I'll let you introduce yourself properly in a second, but kind of our history goes back a little while, and we kind of worked together on a few of the open source projects. And one day I got this email out of the blue from Josh saying, "Hi, you might recognize me from the MultiQC repo. I'm in Stockholm. Do you want to grab a beer?" and Josh, we sat in a Stockholm pub having some good beers, chatting over like Nextflow and MultiQC and stuff. And ever since then, I've been threatening to get you on a podcast. That was what, like a year and a half ago now or something? Can you remember?
Yeah, probably about 2 years ago. Yeah, you gave some great recommendations. That was a lot of fun.
So anyway, I'm really happy that we finally made it actually happen, and I've got you here, and we can sort of dive into some of the amazing kind of cool stuff that you guys are building. So let's kick us off, Josh. Who are you? Where do you come from? What's your background, and how did you get into all this stuff?
Yeah, great question. So I'm Josh. Originally, I was born in Toronto. I guess most of my career has been in Silicon Valley. I've worked at Uber, Docker, Snapchat, and I guess mostly at Stripe, particularly managing cloud infrastructure. A few years ago, my brother approached me and convinced me to make the hop to working on bioinformatics challenges. And that's really when we started BugSeq. And so BugSeq is an automated bioinformatics platform. And really our goal is to enable labs to adopt and scale sequencing by providing turnkey analysis solutions. So we focus on infectious diseases and we serve public health and clinical labs. We support bacteria, fungi, and viruses. But really the way you can think of this is analysis is obviously hard. What if you could just drag and drop raw sequencing data and in a few hours get a rich report? So no need to worry about infrastructure. As technologies change, no need to build out new pipelines. It all just kind of happens seamlessly. And for labs, they can focus on whether it's the epidemiology side or whatever they're trying to focus on without needing to manage the IT side. So I've worked primarily in cloud, and now I oversee all of the development, the tech side of BugSeq.
So BugSeq, maybe we can go into a bit more of this in detail in a second, but who are your kind of typical users? Are they bioinformaticians or are they kind of people working in the lab? Or
we primarily serve lab folks, and so I'd say the lab techs typically do the sequencing and they'll be submitting the data, and then it'll be the epidemiologist all the way up to the directors that interpret the reports that we give and make the actionable decisions. We do have a cohort of bioinformaticians that kind of use us as well, but primarily it's how do we go from that raw data to actionable results as quick as possible.
That's cool. And there's quite a list of companies you reeled off in Silicon Valley. I can see why your brothers was trying to get your skills.
Yeah, we have a good time together.
Yeah. And so you're CTO at BugSeq, is that right? And I guess your brother founded BugSeq, or you founded it together, or
yeah, exactly.
How did that
kind
story
of together.
play out?
The origin story is quite funny. I'll try and condense this, but I was visiting him in Vancouver, and he was doing residency at the time and mentioned that lab to lab, they were all starting to adopt sequencing, and they had him kind of pulling some open source tools off the shelf and trying to wrangle some pipelines. And then he would shift to the next lab and basically do the same thing. And so he said, "Josh, I kind of scripted this up and got it working." He had actually pulled a full stack framework off the internet. And he said, "I want to post this on the web so folks can just drag their files over. It'll upload to our server and it'll run it was a shell script at the time, and it was basically running Nextflow. And then it'll spit out results for them. And so all of the labs I've worked at could use this." And I said, "Okay, yeah, sure, whatever." And so I helped him get it on the internet. And he posted it on some forums, and within a few days, it fell over entirely. So I was like, wow, people are actually using this. And, obviously from a pride perspective, you don't want to throw something up that just falls over. And so we productionized it, got it working. And I guess as the weeks and months rolled on, we started working with bigger names. from just, standard state public health labs all the way up to the CDC. And so it kind of just morphed from, hey, here's a pipeline, to now we do all different kinds of analysis for all different kinds of customers.
It's really cool. And like so many projects that I've been lucky to work on, and it sounds the same, it's almost kind of a by accident type situation. You're like building something you see an immediate need for, and it fills a niche.
Yeah, exactly. It's like we're just trying to solve a problem for us, and all of a sudden it seems it was actually useful.
Yeah, awesome. Very cool. So then tell us, before you go back to that, so you kind of touched on your earlier stuff with full stack and cloud. Like, you're presumably not a bioinformatician by training. You kind of, did you study computer science or something, or how did you get into that?
Exactly. My background is in software engineering. I went to school up in Canada at the University of Waterloo, and I'd say primarily I've been managing infrastructure. Worked on everything from storage to deployment to compute, mostly AWS, and obviously that's very valuable here. And so I've kind of been brushing up on the bio side and evolving over the years. And Sam is now a full-fledged software engineer, and we have a team of folks that help us out. And so kind of learn skills as necessary.
Very cool. Very cool. And you're a Nextflow shop from the start, and MultiQC as well from the start. I think our first interactions were on the MultiQC repo, if I remember right.
Yeah, exactly. I'd say Nextflow and MultiQC play a core part in how we do things. Obviously, Nextflow is more behind the scenes, kind of the pipeline brain that powers things, and MultiQC is very much in front of the scenes, the things that our customers love and interact with. So we use both of those. I'd say we write pretty much all of the processes in-house. We obviously use a lot of open source software. We try and contribute where possible. And we'll probably touch on this a bit later, but effectively build a bunch of Docker images. We run everything on AWS. And so our analysis all runs on batch. We're situated in multiple jurisdictions. I guess not necessarily by choice, but customers, obviously are pretty strict about where their data lives and security posture. And so we're able to comply with those requirements by spinning off jobs in the various jurisdictions that they reside in.
Nice. Very cool. And so were you around when Nextflow was chosen, or was that kind of already part of the stack when you got involved?
Yeah, we talked about it. And I guess the decision was primarily based on what's popular for bioinformatics folks, because at the end of the day, those are the core target markets that we serve. And so kind of tech is important. It's important to make sure that it works properly, but it also has to fit the domain. And so at the time, most folks building out sophisticated bioinformatics pipelines were using either Nextflow or SnakeMake. And Sam sort of brought the industry side. That's what he had seen most labs using. And so instead of going against the grain, we figured we may as well embrace it and try and adopt it, fix bugs here and there. But largely, it's been solid and helped us grow without worrying per se about the infrastructure side of things.
That's cool. And so I imagine you put it through your paces, like through its paces. How many kind of samples, and is that something you can share with us? Like, have you managed to take it down yet?
Well, it's an interesting question. So we do many thousands of samples a month. Most of our customers are on a subscription basis, and so it's effectively all you can eat. And they always ask, unlimited, and it's like, yes, truly unlimited. And so you obviously get some customers who try and push the bounds. We've gotten kills and stuff like that, like out of memories on Nextflow. I'd say by and large, it's been pretty solid. Most of the bugs we hit, most of them come from us. And a lot of the scalability is things like hitting S3 rate limits or, ephemeral things that you can paper over with retries. But by and large, I'd say in terms of interpreting input data and fanning out tasks, Nextflow is pretty straightforward in that. And in terms of scalability, we haven't really hit many issues at the Nextflow layer itself.
And you're still using the kind of vanilla Nextflow. You've not need to fork it or anything like that. You can
yeah,
shape it however it needs.
No, we don't fork it. We just use it as is. I would say we've added shims here and there where necessary. most of it compatible with Nextflow. So things like adding jars as libraries, and we'll go into that a bit, but more incorporating things into our pipelines.
Yeah. And how about, is it a similar story of MultiQC? Like,
yeah,
is it all kind of stock modules or plugins or how?
Yeah, good question. So MultiQC, we do use a lot of the stock modules. We write a lot of custom content. A lot of our value proposition is how do we make sequencing actionable for labs? And so just, handing them an 85-page report is not necessarily useful. It's bubbling up what pathogenic organisms are present or the right antimicrobial resistance, bubbling that to the top of the report that's very valuable for them. And so a lot of it is tables and charts that are custom content, and we sort them in the right way. Nothing too sophisticated, but it's a lot about presentation and making sure it's the right information. We do maintain a fork. It's public. Sam asked me the other day, hey, can we stop doing this and just get everything upstream? And I was like, every time you review my merge requests, it's different patches because they do all get upstreamed. Typically, we'll just battle test things. And, if I'm not positive something is useful to the open source community, we'll run it internally for a bit, make sure that it looks good, and then we'll submit it to upstream. But in terms of the commits that we carry on top of MultiQC, it's all up there. Like none of it is secret. It's more just making sure that it's right for the open source project before actually submitting a merge request. So one example of this recently is we got a request to do natural sorting of sample names. And so natural sorting, for folks who aren't aware, means that if you have a number in the middle of a string like 100, that will come after 99, whereas typically you'd think that 1 goes before 9, but it's smart enough to interpret numerics in strings. So I did go ahead and do that, and I probably will submit the patch at some point. But by and large, all the changes we've made, like custom CSS and different things, have made their way into upstream, and you all have been phenomenal to work with.
That's cool. Yeah, no, and I think sort of your background as a software engineer kind of shines through when your pull requests come in, because I'm like, it's like small, manageable, well described. He's put in lots of code comments. it's sort of like we get a full range of different kind of contributions on the project, but it's good. And just for anyone who's listening who's not super familiar with kind of the nitty gritty of MultiQC, it comes with modules which recognize output from standard bioinformatics tools without any customization. And what you're talking about, custom content, it's basically a way of saving whatever data you want, whatever numeric data, as long as you use the standardized file format and structure. MultiQC can ingest that and inject it into reports.
Yeah, that's exactly right.
Very cool. Okay, right. Let's take us on to some of these cool things you're doing. Then, like the first thing I've got written down here is some stuff around testing and continuous integration. What kind of constraints and what priorities are you working with here?
Good question. So I'd say one of the biggest frustrations with bioinformatics is you hit go on a pipeline or you pull a tool off the shelf and all you want is the answer, and then it blows up in a new way every time. And so we need to make sure, obviously, at scale that our pipelines operate reliably. We can't have a human shepherding every sample we get through a pipeline and making sure that things are working. Ultimately, we need to be resilient to failures. And so part of that is making sure that all code that gets merged into our main branch and eventually production actually works in our pipeline. There is two classes of error, I'd say, that we hit most often. One is just silly typing errors where data can't actually flow through Nextflow. We have obviously a sophisticated mesh of pipelines, hundreds of different tools that execute different workflows, depending on what kind of sample user submits. So depending on whether it's Illumina or Nanopore, depending on whether it's an isolate or metagenomic, we'll kind of funnel that data through different pipelines. And we do a lot of joining and then fanning back out. And so there's a lot of data being passed around. And I think folks who have worked with Nextflow are used to seeing things like 6 tuples going into a workflow and then, trying to make sense of them on the way out. And so a lot of the kind of rudimentary issues we hit are just we fed in too many items in a tuple, or we didn't declare an output on a module when we meant to. And obviously, you run your code and you hit this right away and you see that. But at scale, when you have a bunch of developers, someone adds a feature, they never foresaw that it would be called in a certain way, and then you get these issues. And so that's one class of issue. The other class of issue that we hit is just a module, the actual script that we're running doesn't do what it's meant to do. So either it can't handle, a gzipped FASTA and is only meant for FASTAs or whatever. And so in order to mitigate both of those classes of issues, we run a lot of pipelines as part of CI. And when I say a lot of pipelines, some of them are end-to-end. So we'll feed in, a tuberculosis sample and let it run through our entire pipeline, and then we'll validate the results. Or some of our tests are just run this one module on this input. And they obviously both have their pros and cons. In order to catch issues of the first class where data doesn't flow properly, you need an end-to-end test. But in order to catch logic issues, you want single module tests. So those are kind of the two classes of testing that we do. In terms of when we run tests, as our developers hit the merge button, their code is reviewed, it's ready to go, they've written tests, they hit the merge button. We'll then go and build any images required that we don't already have, if they make a change to an underlying image. And then we'll go and run all of these pipelines, and those run on AWS Batch. We'll aggregate all the results. We use PyTest workflow, and so we can do basic things like checking a PDF report has some right keywords, and then we can do very sophisticated things like ingesting JSONs and checking for specific contents, or even I mentioned to Phil that we slurp in MultiQC reports the full HTML in beautiful soup, do some parsing, and then make sure that tables have the right contents in them. And that allows us to build confidence that as we upgrade certain software packages or write new pipelines ourselves, the user results are always staying consistent. And so they can count on us to get reliable, reproducible results from the data that they submit. I'll pause there.
For anyone who's wondering what on earth is beautiful soup, that's the name of a Python package that can parse HTML.
Yeah, so that's exactly it.
Something that sprang to mind as you were talking, like how much of your work is presumably you're working with healthcare samples. Do you have a lot to do with kind of accreditation, and do you work with like the FDA or anything like that?
Yep, we work with most three-letter agencies. Some we can talk about, some we can't. One thing that's public is we do anthrax analysis for the CDC. And so obviously they have certain requirements around data locality, also around runtime and around accuracy. And so we offer versioned pipelines. And so if you think about, open source projects stamping a revision, we do something similar and actually have a blog post up about this I can share after. But the gist is, as a lab or an agency, if you onboard and submit data, you should be confident that you'll get the same results every time. And often getting, ideally the results are correct, but often getting reproducible results, even when they're not correct, is more important from a scientific perspective than getting different results every time. And then you can't really count on whether the pipeline is doing something reliable and deterministic or not. And so we do have versioning from the software perspective, all the software packages, all the way down to all of the databases we build. And that tends to meet that requirement. But also we just want to make sure that, we don't wholesale cut out an arm of analysis or something big. And so we run a lot of testing for those folks to make sure that things look correct.
And does that kind of testing, is that its own separate thing, or does that tie into all this automation and the CI/CD stuff that you're doing?
All of our tests run in CI/CD. So any code that hits our main branch and then production has run through our full suite of tests. And I would say our tests catch more issues than we'd like, but also the right amount of issues. And so ideally, the software and infrastructure would be structured such that you don't write bugs in the first place. We can all dream, but bugs are fairly common, and usually it's in places you would least expect that something blows up. And so having robust test coverage around all of our pipelines and the processes that they run enables us to catch most issues except for the hairiest of logic bugs before they hit production.
Very good. And you mentioned you're using PyTest workflow. There's a beautiful piece of software I've been using at an NF Core for a long time. It's got some really nice functionality. In NF Core, in the last kind of year or so, haven't quite finished. We've started this process of switching from PyTest workflow over to NF Test. I don't know how much you know about this project. Is that something you looked at NF Test yourselves, or are you have you got too much buy-in with PyTest workflow at this point?
We haven't evaluated it. I would be very open to it. I think PyTest workflow, there's things that are going super well and things that aren't. Primarily, I'd say the value add to us is just the suite of validation logic that it can run on outputs. So we run a lot of the custom Python. You can effectively define after this workflow completes, run this Python stanza and validate things. NF Core may have something similar. I'm not sure. I would say that's the core value proposition we get out of it. In terms of pain points, we've recently started looking at parallelizing Nextflow executions because originally we stamped out one GitLab CI job per test effectively. And the cloning with recursive submodules and all of that, and then firing up Nextflow from scratch, and then waiting on batch to actually execute tasks and gathering all the results has gotten quite expensive. So it's kind of a necessary expense, but we'd obviously love to drive that down. We've looked at parallelizing PyTest workflow, and so they have a worker threads phenomenon, and obviously that plays interesting with Nextflow when you're running multiple processes on the same box. So we haven't quite gotten there yet. I think we'd be super open to ripping it out and looking at something like NF Test if it met those criteria. I think going forward, there's a few kind of going back to the classes of issues that we detect. I've looked at the Nextflow stubbing and been trying to think about, is the right way to test pipelines end to end actually to stub all the processes so you can run it in 10 seconds instead of 10 minutes. And obviously there's pros and cons. Nothing necessarily validates that the process actually outputs those contents, and so you got to keep your stubs up to date. But that's one mechanism I'd love to investigate further. The other is I can get into the details later on how we build our images, but I'd love to start running tests of the modules in our Docker images just on the local machine. And so you could imagine, similar to unit tests at a big company, you can run 1,000 of them in a second. And so if we could run those, the whole value of Nextflow and testing is that we get to run things in containers on the cloud. And if we could run things in containers one after the other without waiting for the whole pipeline, we might be able to catch some bugs a lot faster. The way that we structure modules is effectively as a Python script. Each module is a Python script. And so each one has a main function, and there's no reason you couldn't just call that main function similar to PyTest as long as you had the dependencies required to actually run it. So we have hundreds of Docker images, so you need to fire up the right one and run the right script in it. But that's another avenue that I'd be interested in exploring.
That's cool. And thinking about a cold start time, have you played much with using AWS Fargate to kind of run stuff on?
Yeah, we do use Fargate. I guess we use it we use it to build our images. So we use the GitLab bridge to Fargate, and I had to write some plumbing there, but effectively every merge spins up a Fargate container. We don't use it for our core pipeline. At a time, we ran monitoring on the underlying host instances. And so monitoring for things like disk space and kills, like we tail the syslog or whatnot. I forget if it's dmessage or the syslog, but we do run some underlying host monitoring. I think it's gotten less relevant over time. So it's quite likely we could rip it out. I always forget if Fargate supports EBS, but we also, for some of our processes, use EBS as the backing store. So it's something we'd be interested in. I'm a huge proponent of Lambda and Fargate. Obviously, where we can offload complexity to AWS, we'd love to. I saw that Nextflow is kicking the tires with introducing Fargate runners. And so that's something that we'd be interested in.
Yeah. Yeah, I messed that up on the last podcast. I said it wasn't merged yet, and then afterwards I realized it had just snuck in before Christmas. So
Yeah,
I think that is in a stable release now, the Fargate support for Nextflow jobs as well as the head node.
yeah, yeah. I would be interested in that. I don't know things like GPUs if it supports that, and like the devil's always in the details.
Yeah,
But yeah, it's something that I imagine like in 2 years we will be fully on serverless. Like I don't want to manage servers as much as the next person. So
yeah, yeah, absolutely. So when you're in Stockholm, you introduced me to a term that I've not really heard many other people use, and you tried to explain it to me. I can't remember very much of it, so I'm hoping you can do the same again tonight. Protobufs. You were talking about the Protobufs library and what it is and how you used it and why you thought it was cool.
yeah. So I guess I'm no expert on the historical part of Protobufs, but my understanding is they came out of Google as interface definitions for services to talk to each other. And you can think of them as typed interface definitions. So something like JSON, but with typing. So you can have a string field and an integer field, and the fields are obviously named. And you use that to consistently serialize and deserialize objects in multiple places and be able to rely on fields being present. And when Sam and I started on our pipelines early on, we realized a gap where you can feed a file into a process, no problem. But as you start to grow and need to make sophisticated decisions like nanopore samples should go down one pipeline, Illumina down another, TB samples down one pipeline, HIV down another. You need this rich metadata to make decisions in multiple places. And so one way you could do this is, you have your file, say a FASTQ file, and you can create a text file beside it and feed both of those as a tuple into a process. But a text file depends, how you parse it, and you're probably asking for trouble if you're really relying on these things and parsing them in the same way. And so you can define helper functions, but this problem starts to look a lot like trying to shuttle structured data between different places. And so there are a bunch of projects that solve this in different but similar ways. So, Thrift, Protobuf, there's Avro, there different companies take different approaches. We just wanted something similar to JSON that could be passed between Nextflow and our processes and contain rich information and be extensible over time.
Right. So
So
let me just reiterate the kind of problem here, just to make sure I understand it. You've got Python scripts running inside your Nextflow processes, and they take inputs which are not necessarily file based. Most Nextflow's got such good handling of files, we tend to say that to people if they ask. It's like, yeah, just write that variable or whatever, that metadata to a file, and then what your script can pick it up and load it. But you're kind of trying to avoid that step, basically. The other way you can do it, of course, is with like command line arguments to your script or something. But here you've got kind of somewhere in between where you can pass rich metadata out of a Groovy value channel, presumably. Use Protobuf somehow, serialize that rich metadata, and then directly load that kind of those variables into your Python script. Did I get that right?
yeah, so there's two sort of concepts I would separate here. One is a transport protocol, or a way of getting a blob of data from one place to another. And the other is what that data actually is, or how it's structured. And so in terms of getting data from Nextflow into a process, in some cases, we'll serialize a proto to a file and stage the file in. In some cases, we'll template it straight into the script. But I would say the value is a lot more on the second side, which is the structuring of data, having a common definition of an object between our Groovy code and our Python code. And so I've noticed in a lot of upstream Nextflow projects in Groovy, there's, if some condition, then the script will actually run one command. If some other condition, the script will run a different command. So we have shifted this logic into our module, into the script itself, the template, and that makes it a lot more testable and also lintable. And so we can talk about linters after, but standard Python linting actually understand our types and are able to see, oh, this is a sample has a species ID field in it. It's an integer. So you can check if that integer is equal to the tax ID of whatever, tuberculosis or something like that. So largely it's a way of serializing data alongside a file, staging both of those into a process, and then being able to make very rich, informed decisions based on the metadata you're dealing with.
Nice. Well, I like that idea of actually having properly typed data with custom Python classes and objects and all that kind of stuff all the way down.
Yeah, exactly. It's helped us eliminate a lot of classes of bug, I would say, where you never have to worry about what fields are present. You have a sample or a genome or whatever metadata it is, you deserialize it. Either the deserialization fails or you can count on the fields being present and make decisions based on them.
Yeah. And I guess this is particularly useful for you because basically all of your processes are running scripts written by you. I'm sort of thinking about how I would use this in some pipelines, but most of the pipelines I've written are just running command line tools, kind of vanilla, if you like. In which case, each of those tools would have to support Protobufs, which is not going to happen. But if you have wrapper scripts around it, then it's sort of you have that complete control, I guess.
Yeah, that's one of the things early on. We started running just shell scripts and found even things like pipe fails, like when piping data fails, sometimes this would blow up and sometimes it actually wouldn't. And we just end up with erroneous empty files. And the lesson we got very early on was that Bash was very hard to scale. And obviously you can run infinite linters like shell check. They may be context aware, they may not be. But ultimately having the power to run some command line tool and then loop over the results and do some crazy munging of data, pull in Python libraries like PyFastX or whatever to help munge data and then spit it out in our own format has been invaluable. So we do definitely shell out, but we do enforce wrapping basically all shell commands in a Python script so that we get the testability and linting and sanity of a proper language versus just running bash scripts.
Yeah, makes sense. And I guess there's kind of a running joke within the Nextflow community that so many people are kind of working within data science and bioinformatics, and Python is this super popular language, and this almost is kind of bringing your Nextflow pipelines a bit closer to the Python world, because you can have more pipeline logic inside Python scripts rather than inside the Groovy code.
Yeah, that's exactly it. And I think you think of, scaling and hiring up bioinformaticians, and the ins and outs of Bash are not necessarily a skill set that you see every day in the wild. But most folks know how to Google for a Python library and make use of it. And so that's helped us be more productive as a team and also catch issues.
I'm totally biased here because I'm a Python fanboy. I'm unashamed.
Yeah. I mean, pick your language as long as it's not Bash.
Yeah, exactly. Yeah. That's a common message through all of our workflows, I think. Yeah. Very cool. Okay. And so, how has that impacted how you build your pipelines, and how's it scaled? And are you happy with it? Presumably, you're still using it.
Yeah, I'd say it's become more pervasive than I could have imagined, where basically all data flowing through our pipelines is a file and then metadata, sometimes multiple files. So for paired reads, you'd have both files, but pretty much anywhere we have a channel, it's tuples of file and metadata. That has scaled really well. The Python part also, we've pulled in a lot of open source Python tools. That's been invaluable for us. I would say pain points are making sure that obviously in Nextflow, when it templates into a script, it doesn't necessarily understand how to template in a rich Groovy object. And so you need to serialize it to a string or bytes and then have it templated in and then deserialize it. We have helpers that do this. Like, we've defined helper functions that are called all over the place. Going back to testing, it's not uncommon we forget to deserialize an output or serialize an input, and then things blow up in really weird ways, and the error messages are actually really hard to understand. So I'd say there is some pain. It's not free. Given Nextflow has the ability to output a graph of your pipeline. And so I once ran that, and, as this enormous web of all these different branches. I don't think there's any way we'd be able to encapsulate that logic just relying on text files. Even parsing JSON into Groovy structs, it would just be heinous. And so having some sort of sanity or structure to the metadata that we pass around, having our processes be in a high level language that can be properly linted and type checked, all of these kind of together mean that we catch most issues before they hit our main branch.
Yeah, I probably should have asked this earlier, but my feeling from the way you're talking is that most of your pipelines are kind of more on the mono repo end of things, where you have a very big pipeline that does a lot of very different things, rather than having quite small pipelines which you choose between which one you run. Is that about right?
Yeah, I think there's like code structuring, so mono repo versus multi repo, and then there's pipelines. Even within a mono repo, you can have many pipelines. So we do define a lot of different workflows, and we do test the workflows independently. A lot of them feed into each other. So we'll call one, and then that'll feed into another. And some of our workflows, just for modularity, will break up when you would never actually call them separate, but it allows us to reason about inputs and outputs in a modular fashion. But yeah, I am more on the mono repo side. I think, working at some of the bigger companies, either they start off with multi repos and make them look more like a mono repo, so you have to build tooling to run things like code mods or across all your repos, or you start with a mono repo and make it look more like a multi repo. And so things like different build stages and combining results. So we're on the mono repo side. We do use Bazel, which is historically used to build big mono repos, like Google uses Bazel, Stripe used Bazel. And so it's quite pervasive. But we are sort of at the core a mono repo, mono pipeline that then fans out to a bunch of other pipelines.
That's cool. And I mean, BugSeq's been around for a little while. Did you start off with writing DSL1 Nextflow pipelines and have to make a transition at some point, or was it always been DSL2?
We did start with DSL1, and I think now you don't even have to specify DSL2 in your pipelines. We still have it littered across our code base. So we did at one point. I don't even remember the migration. Like a lot of these things early on, Samurai would just cut a merge request like migrated to V2, and it's just like thousands of lines, but our testing really comes in handy here. And so I don't remember what the migration quite looked like, but now we're fully all DSL2. I don't even think you can write DSL1 anymore.
No. I mean, the Nextflow will just refuse if you try.
Yeah.
Okay, cool. And then anything else? So I've got in the notes one more thing you said about the Protobufs about Docker images. Is that? Can you explain what you mean by that?
Sure. Yeah. So obviously, as you're running diverse pipelines, you have a broad set of requirements from a software perspective. And so there's, pip packages, conda packages. Sometimes you need to run Perl scripts, or some of this we write in-house, and some of it is just out in the ether, and it's the best tool for the job. And so obviously, I'm not going to propose we rewrite the world in Rust. If something is in Perl and does what it needs to do, we'll just grab that thing in Perl and run it. But this is all to say all of our processes need a runtime environment with the dependencies that they depend on. I've heard the idea of like, can't you just install everything in one super image? And the answer is no. Obviously, as you scale, things start to conflict, dependencies start to conflict. Even on some very small scale processes we'll get a conflict of dependencies and need to pull it apart in Nextflow, where we otherwise would have run it as a single module, but we can't get all of the packages that we want in a single Docker image. So we build a lot of images, and in those images, we put third-party tooling, but we also put a lot of our own stuff. So we have helpers, for example. We talked about the protos. So those definitions are serial or our Python code. They're compiled into Python code, but those go in our images so that when we deserialize, it can actually do the type checking. There's also helpers like outputting MultiQC formatted custom content. So we have a lot of helpers that we bundle into our images. So first party, third party, a bunch of code in there, which means that as we make changes, we end up needing to build a lot of images. And one way you could go about this is, store the version of an image like V1, V2, and I go and make a change to an image and I bump that to V3. But you could also imagine, baking in a Rust binary to the underlying image, and then you change that and you need to wholesale bump all of your images. And what if you forget? Then all of a sudden you're running your pipeline and it thinks there's an updated image, but there isn't. So what we do is we automatically generate the version we have 100 odd images, and we automatically generate the tag or the version from the dependencies that go into the image. And Bazel actually makes this somewhat straightforward, because your image is, without going too technical, your image is a collection of layers. Bazel is smart enough to build each independently, and it can hash them and give you a unique identifier similar to an image digest. And so we effectively use that as our version. If any of the dependencies change, the image tag changes, and that breaks the Nextflow cache. And then the tests are smart enough to do caching, but know to rerun that process, and all kind of works out. So we have had to get clever about how we build those to meet the caching semantics we need, but also make sure that we're always running the right code in the underlying image. But also it's been super powerful to us to be able to have all of these different environments that we can pull on whenever we need. So if we need pandas, there's an image for that. If we need MultiQC, there's an image for that. And then if we need to add pandas to our MultiQC image, we can also do that fairly trivially.
Nice. I got to ask, have you thought about using Wave at all? I know that you probably built most of its infrastructure before Wave was around, or certainly before it was open source. But this sounds like a similar kind of thing that we built Wave for, which kind of injects dependencies into existing Docker containers and Docker images, like on the fly.
Yeah, we've definitely thought about it. I would say I think CI and building core dependencies like Docker images is really hard. Most big companies will have entire teams devoted to that. And so it's, we want it to be a separate process from runtime. So we don't want to just be willy-nilly injecting things. Even if you can version them, there's something nice about, ahead of time having a testable image that's relocatable. We can run our tests in it and then promote to production. So I definitely am cognizant or careful about CI and building images should be its own process, and then runtime should use pre-built artifacts that are set in stone. And then when things go wrong, you can pull your artifact. I think you can do this with Wave, like it injects some dependencies and then pushes it to your repository. So in theory, you can pull it back out. But I think that CI and dependency building sort of conceptually is separate and also a very hard problem. And we probably don't want our runtime depending on it. Another interesting issue that comes up is build provenance. So typically at a big company, you'll want to make sure that you're resilient to supply chain attacks and that your builds are in a separate environment. And, someone can't just download all your production data because they owned a build or something like that. And so I think just in general, we want to keep our build and runtime separate. I don't know if Wave is amenable to this. It may be. Last time I looked, it was kind of like you run a process and then things get injected and you kind of hope for the best. And if things fail, that kind of thing. But it's something we would consider at some point.
Yeah. The way you've kind of structured the conversation is very reminiscent of some of the discussions we've had in NF Core lately. And out of the box, Wave does everything completely on the fly at runtime. There's kind of the attraction of it being super user friendly is you just don't need to think about the fact that you're using containers at all. They're just magically there. But if and when we start adopting it in NF Core, we'll probably do basically what you're saying, which is do the Docker image builds using Wave separately, push them to a repo, and then fix those container images within the pipeline code.
Yeah. The other thing that you can't really express in Wave and even really in Docker is suppose you have an image that builds a Go binary, a Rust binary, and a Conda environment. In, let's just say, a Docker file, you can't hint at Docker that one stage is kind of not related to the previous one. And so you can start with multi-stage image builds. Like there is a way to structure it, but your one Docker file cannot then pull in another Docker file. And Docker doesn't build a build graph for you and understand what it needs to build to put into your image. You can't just run one command to kind of do that. versus Bazel can. So to give a concrete example, if we change an underlying dependency, ordinarily, and the way we used to do this is you'd have a base image, we change an underlying dependency, and then it would have to resolve the Conda environment, which is really expensive. Versus with something like Bazel, the Conda environment is one target, our underlying dependency is another target. One doesn't break the other. If you change the underlying dependency, this tarball stays cached. They both go into a Docker image, and then that just gets packaged up. So the caching semantics are a lot better using a proper build system that understands a dependency graph versus kind of a linear build from the ground up.
Cool. I would like to continue this conversation another day. So I think we could. I'm a bit worried of going down the rabbit hole of Docker builds. Yeah. It's a deep hole, but that's cool. And I've not heard of Bazel before, and I've not really heard of this way of managing Docker images before. So it's really interesting to hear about.
It's really unintuitive and insanely powerful if you embrace it. Like most big companies will have a team to bridge the usability gap and the good characteristics you get from Bazel. Now there's actually some startups that try and make it more usable to the masses. If you embrace it, it's incredibly powerful. It can do things like hook into S3 or other storage systems as a cache. And so it has very nice semantics. I think their tagline is fast and correct, pick two. And so you never really... You don't sacrifice apart from, needing a PhD in build systems to figure out what's going on.
Easy.
Yeah.
Good stuff. Cool. Okay. I want to hear a bit more about MultiQC. So we talked a bit about kind of your production Nextflow setup and everything, but switch to the other end of the workflow. Tell us a little bit about how you're using MultiQC.
Yeah. Firstly, we love MultiQC. I think the best way to describe MultiQC for us is it's a bridge between bioinformaticians generating data and users interpreting data. And so users choose BugSeq because we give them actionable reports, and a lot of that hinges on our ability to take something like a pandas data frame or a JSON and turn it into an interactive either table or chart that folks can actually poke around and understand. So throughout all of our workflows, we typically have an output channel, which is straight into MultiQC. And we will, for any data submitted, we'll typically run MultiQC in two ways. One is as a general summary report. And so it just contains high-level at-a-glance information. And then for each sample, we'll produce a standalone report that has a lot more detail. And so typically customers will crack open the summary report first, pick which line they want to go dig into, and then go to the sample report and look at the specific item of interest. In terms of how we use it, we mostly feed in custom content and outputs from common tools. It's been good. We definitely appreciate some of the recent performance improvements. I'd say in terms of rough edges, sometimes it's just hard to figure out, if you want to order certain sections, what keys do you use in the config? And then the other thing I would mention is stability. So I think, kind of for Nextflow and MultiQC, we need to invest a lot in validation before we can upgrade versions, because there's always some nice surprises in store. But generally, I would say it does what it says on the tin, which is we can write data that as programmers makes sense to us, like JSON, and then our users on the other side can interpret it the way it makes sense to them as, oh, this slot is red, I should probably look at that cell or something like that.
Yeah. I can say on my side, the custom content feature that it sounds like you're using quite heavily was almost an afterthought. It's one of these things where I was like, oh, I wonder if I could do this. This would be cool. And then the popularity sort of like skyrocketed much more than I expected. And I've sort of felt guilty about it ever since, because I agree some of the config that you have to do. But like, and also the documentation has never been that up to scratch. Whenever people ask about custom content, I can't tell them the answer straight away. I'm like, give me a file and give me half an hour to mess around with it, and I'll tell you how to do it. But
Yeah, I've
I
even
have to
thought
go into
about.
the source code more often than I like to find that answer.
Yeah, exactly. One of the things that's crossed my mind is like, should we internally write helper libraries where you can feed it a data frame or a more intuitive table format, and it will spit out, the proper column configs and possibly coloring or things like that. And like, there's no reason this couldn't also live in MultiQC. But I'm, cognizant of imposing interfaces on other things, and like it generally works well enough. So we can use it. It's more just getting it set up initially. Adding a new process that outputs to MultiQC is like a lot of smashing your face on the keyboard before it looks great.
Yeah, I appreciate that. We talked in previous episodes about the kind of roadmap for 2024 for Nextflow. I haven't talked very much about MultiQC in this podcast, but if you go to the repo, there's a bunch of issues there, and one of the things we're eyeing up is replacing that custom content format and with something better. And we're thinking about exactly what you're suggesting, a better structured data format, quite possibly something like Apache Parquet or something. And then also the other thing is we want to refactor a whole bunch of MultiQC internals using much stronger typing, using probably something like Pydantic. So then we'll have actual proper schema when you're like developing these configs and stuff, and hopefully even your IDE will be like telling you which things you can put here and there, and might be a bit of a better developer experience, I'm hoping.
Yeah, I would love that. I take it one of the few that imports MultiQC as a Python module and actually just calls multiqc.run instead of using the CLI interface. And so we actually would be able to catch issues of that shape. Like we would just pull in the MultiQC classes and use those directly. And hopefully it would blow up either at lint time or even at runtime. Telling you that your data is structured wrong loudly is always better than just finding an empty table. So we would definitely be interested in something like that. The other thing I was talking with, I think it was Vlad, one of the maintainers recently, was about better module tests. And we'd also be super interested in contributing a bunch of those to make sure that, as tools evolve, you're always like we can upgrade a tool unrelated to MultiQC and then find a table is missing from the report. And so making sure that, it maintains compatibility over time.
Yeah, definitely. Proper unit testing has been an Achilles heel of mine through this. That's one of the telling aspects of my non-computational background is like sort of like a bit struggle with that, with discipline. But proper unit testing is definitely something we want to invest in. And maybe it could even be like a good kind of multi-QC hackathon or something to try and get people involved in scaling those out. I'll have to look into that. Very nice. And and importing MultiQC as a library, like you say, is kind of difficult to do that. Like I had a really good intern a while ago, Eric Danielson, and he had a look into it and made a little bit of progress, which is why it's possible to do that at all. But it's still a bit clunky. And part of this refactoring is I would love people to be writing Jupyter notebooks and scripts and stuff like that, and like you say, pulling in functions and building their own custom. It doesn't even have to be a MultiQC report. They're just their own analysis reports using MultiQC functionality. That'd be very cool.
Yeah, I think even on the config side, like we actually, from a Python process, stamp out the Nextflow config to a YAML file, I believe, or we may pass it in directly. But having type checking there would also be in that. Like you could see the whole thing being typed end to end, which would be incredible. So we're interested.
All right, let's have another podcast in 6 months or a year, and we'll see if we've got there.
Yeah,
good stuff. Nice, cool. Okay, and hopefully we can be a bit more sort of enterprise stable, if you like, with all that kind of that new refactoring that's coming up.
Yeah, it's always tough. It's like, it's kind of our fault for upgrading, but also it'd be nice if you always want both, right? You want to run the latest and greatest and for it to be stable. So I'm cognizant that that's not a super realistic expectation. And, we're happy to help kind of maintain as we can.
Very cool. All right. So it's kind of final topic, I guess. Like, you've got here, I think it's quite an interesting topic. It's kind of how you're working with the kind of production grade usage of these tools, and obviously you're working with clinical samples and clinicians, and there are real consequences to things going wrong. Tell us a little bit about how that works and how you deal with that responsibility.
Yeah, absolutely. So we obviously, typically at a software company, you talk about nines of uptime. And even though we're running batch or asynchronous processing, you still want to maintain some rigor in terms of uptime. And I'd say even more consequential than at a typical software company, if a shift can't get the results they need in a single shift, that actually impacts patients. And so we take a lot of responsibility in making sure that we deliver the right results, but quickly. And part of that is running a productionized critical system, like you mentioned. So basic things like having a pager rotation. So when something blows up, someone at least gets paged and can look into what's going on. Making sure that when code does hit production, it's typically production grade. Another thing we do is we use the NF weblog plugin and basically pipe all of our processes into a database. And then we have a UI where any process that succeeds or fails, we have links out to the work directory, to the CloudWatch logs, to the batch process that ran, all of the things you might need to dig into, we have right there, and you can search across all the different processes that have run. And this was like, once we thought of this, was surprisingly easy just to pipe everything into Dynamo. There's, I think, an API gateway in front of Dynamo, and Bob's your uncle. So that helps a lot in terms of figuring out, when things go wrong, what actually went wrong. In terms of looking forward, I would love to have like a one-click button. You mentioned Fargate earlier, but something serverless, or just pop you into a shell in the container of the process that ran with all the inputs staged in, and then you can start running your own commands and poke around and figure out what's going on. I don't know if Tower has something like this or if it's on the roadmap. I got to figure someone has thought of this before, but that's something that we would like to have. But yeah, by and large, having everything in a debuggable, centralized, presentable way helps our team dig into issues as quick as possible. The other thing I would mention is, I think, in terms of writing Nextflow pipelines, they're really easy to get wrong, in that inputs, outputs, how you do things like joins. Like recently we had an issue where one of our joins was combinatorial instead of one-to-one. And so it was basically blowing up, like two channels were coming and joining, and we were joining on, to put it concretely, on the genome name. And so if you had 10 samples and whatever, it would blow up combinatorially. And these things happen all the time. Global variables getting mixed up happens all the time, where there will be, a race. And this is one of the hardest to debug. You just get weird results, like a sample suddenly disappears or something. And then you find out like, oh, within this workflow, this variable stamped over a global. And obviously we didn't mean for it to be global, but this happens. So I think there is a Nextflow IDE plugin now, keep me honest here, but something like implementing the LSP, the language protocol, that could actually type check your Nextflow workflows and make sure that they look right before they even run would be super helpful, I think, for our developers too. But by and large, things run, they generally run smoothly. When they break, someone gets notified. Typically, we can figure things out in a matter of minutes or hours, get whatever was running back running. And typically our customers get results within an hour or two. So obviously in that range, it doesn't leave a whole lot of time to really figure out what's going on. You need things to run smoothly, and when they don't, you need to be able to debug very quickly.
Yeah, hour two is quite an extreme level of responsiveness. So when suddenly the cold start on AWS of 5 minutes starts to sound more important.
Yeah, I mean, it's funny, it's like, and like disk caching, all these things. But I remember like working at bigger software companies, I did once cause an outage where one company was down for 45 minutes, and like I can't share the figure, but it's more than I'll ever have in my lifetime. And so kind of like these, you get used to just these are production grade systems and customers pay for that production grade. And so it's kind of on us to figure out what processes and practices we need to be able to uphold those uptime requirements for them.
Absolutely. You also put your finger very precisely on a whole bunch of stuff we're working on this year and with Nextflow. Some of that stuff we've touched on in previous podcasts, but also I definitely love to chat more in depth about how we can better structure Nextflow syntax around these needs. And there's some GitHub issues about thinking about the Nextflow config and also sort of thinking about better structuring inputs and outputs and typing. There's been about a multi-year effort thinking about a language LSP and like different kind of IDE integrations, which is not trivial because of the way that the Nextflow DSL is built, but it's something we are very actively working on. I think it's, for me, is one of the top priorities really with Nextflow development, is trying to improve that kind of developer experience and catch these, not necessarily eliminate these difficulties, but catch these difficulties much sooner. So yeah, it'd be great exactly. To continue that conversation. I'd love to get your inputs on some of the ideas that we're chucking around now.
Yeah, I would love to see. I definitely have ideas. I've worked a lot with Temporal, which is a production grade workflow orchestrator, and all your workflows are strongly typed in terms of inputs and outputs. Your tasks are strongly typed. Things can be mocked very easily. It's just I would just say it's a very well understandable system. It has some glaring foot guns, but by and large, it's a lot easier to reason about what data you have where and how to work with it.
Cool. Yeah. Well, that's enough. We're building up our schedule for next year's podcast. It's good.
Yeah. I'm excited.
Exactly. Cool. I'm going to touch on a couple of kind of standard things in a second, but just to wrap up, is there anything else you want to say? Is there anything we've missed? I don't know, any shout outs to friends and family?
I was actually going to give a shout out to you all, but I feel like one of the things we can't really say enough is thanks. Sometimes I'll throw it in a GitHub issue, but really thanks to your team, both MultiQC and Nextflow. Obviously, we try and give back where we can, but they're invaluable tools for us. And as much as you get frustrated sometimes is natural, like really we couldn't do what we do without them. So thanks to you all for all the hard work and keep it up.
I appreciate it. So it's definitely a productive collaboration we've had. And if anyone's interested in what it is that Josh works on, and the name of the company was BugSeq, and you've got your website here. So go and check that out, and we'll put some details in the show notes. Just before we wrap up, I want to quickly touch on a few upcoming events. If you're in the Nextflow community, you'll probably have been pestered by us in a few different channels already. But the big news of the last few days really is that the Nextflow Summit 2024 is really kicking off. So we're going to be in Boston again in May, and also in Barcelona. And the call for abstracts for Boston is just open. So we're really excited about seeing some abstracts come in. I don't know if you're going to be able to fly over for that one, Josh. It'd be great to.
It's in Boston. There's a good shot. Yeah, I guess I'll look into it, but I am interested in making it to one of these.
Yeah, they're really fun events. So last year was our first event in the US, which was also in Boston, different venue, but same city. And it really, like, we were massive. You never quite know when you kind of start off with a new project. We've never been in the States before. We didn't know how many people were going to sign up. And it sold out in like a couple of weeks. We had to negotiate with the venue to pretty much double the event space. So I'm really excited to see how it goes second time around. See if people still want to turn up. And then on a similar note, then, so that's coming up in May, the Boston Summit. Before that, we've got a few community events which are all on the NF Core website. The big ones are training. So we've got some online training which is free coming up. I think it's like the same day this podcast comes out, so maybe it's a bit too late. But community foundational training, which all ends up on YouTube as well, so anyone can watch it afterwards if necessary and join in person. And then also we've got a hackathon. So we've got our next hackathon is online and distributed, and that's on mid-March. It's free to join. You can either just join wherever you are, and there's also a whole load of in-person sites which are all over the world really. Josh, you're in San Francisco, is that right? Or no, have you moved
Yeah,
there?
I'm based in San Francisco. Yeah.
We're just chatting today on Slack about trying to get a location in San Francisco, so maybe we'll be somewhere on your doorstep.
I'll go. I'll
That'd be awesome.
absolutely go. Yeah.
So take a look and join us if you can. It's a lot of fun. So those are the big ones coming up. Great stuff. With that, Josh, thank you so much for your time today. As always, been an absolute pleasure chatting. I learn an awful lot whenever we actually sit down and talk. So hopefully get you back on the podcast again in the future and dig into some of these topics again.
Cool. Yeah. Thanks so much for having me.
And yeah, everyone who's been listening, thanks for joining. We'll see you next time. Cheers.